And the main reason for that long digression was this is a quadratic function. This is a general form of a quadratic function. And we want the specific quadratic function that models this data, because if we have that function, we can tell where the water level should have been at any time. Okay? And we can tell when the water would have been at this level. Because as soon as we have that function, we can find the value of y for any given t, and we can find the value of t for any given y. And that's a big deal. Okay, so how are we going to get that function? Well, it turns out to be related to something that we do a little more of toward the end of the course, but we want to do a little bit of it right now. And we'll do it in more generality later. So what we do is we say that, okay, first, y is this, but I'm going to write y of t equals at squared plus bt plus c. Now let's say the coordinates of this point are 7, 121. Well, let's say 120. Easier to square. Actually, we don't have to square it, okay? Now, 7 is what? Is that y or is that t? First coordinate of a point on this graph. That's a t, right? First coordinate, second coordinate, okay? So we can now say that, first of all, y of 7 is 120, right? In function notation, okay? So if we plug in 7 and 120 over here, what do we get? We get well, I've written this whole function except for the t's, right? Okay? And t, of course, for this point is 7. So I'm going to put 7 in every place there's a t. Was that difficult? Can you do that? Will you be able to do that with the points that you estimate? Sure. Okay? Look at the video again if you need to. Well, what is y of 7? Well, y of 7 is 120, right? So now we have the equation 120, and 7 squared times a is 49a, and of course this is 7b plus c, right? Okay, now let's estimate another point. This point here, let's see. If this is 184, that looks like it's about, I'd say that's about 90 on the t-axis. So I'm going to say that's about 90. And if this is 145, half of that would be about there. I'm going to say it's 90, 70. Now, when you do your estimate, do an honest estimate as close as you can using the scale of your graph. Don't try to round off to the nearest 10, or you're not going to get a decent model. Try to make the best estimate you can based on what your graph tells you. Okay? So, if we do that, we get y of what? Well, y of t T is 90. And of course, I've left all the, I'm just going to substitute for the T's. Okay? And then, of course, y of 90 is 70. So now I have the equation 70 equals 8100A plus 90B plus C. And then I estimate this point out here, which I'm going to say is, oh, let's say 170/15. So I'll just say, I'm not going to write it out in detail for the third point. We get 15 equals 170 squared times A plus 170B plus C, right? So that 15 equals 170 squared is 28,900 A plus 170B plus C. Okay? Now I've got three equations. I've got this equation, I've got this equation, and I've got this equation. And you're going to be able to do the same thing. Okay? Very straightforward. Now what are we going to do with these equations?